Okay, so here is case 2 example out of class 1 for ES211. Let me see, I'll move myself down a little bit. Okay, so point A oscillates with an acceleration equal to 2,880 minus 144x, where A and x are expressed in inches per second squared and inches respectively. The magnitude of the velocity is 11 inches per second and x when x is equal to 20.4 inches. We want to determine the maximum velocity of A, that point, and the two positions at which the velocity A are 0. So I will I'll move myself again here, and hopefully I will exit out of this show, and let's go to the paper here to do this. Okay, so I will write down what the problem is, and this is case 2 example. And we were told that, let's see, so the given is that the acceleration is 2880 minus 144x, and this is in inches per second squared, and that's in inches. And at x is equal to 20.4 inches, v is equal to 11 inches per second. Okay, so we note that this is a function of position, right? So acceleration is dependent on position. So that's why this is a case 2 example, right? That's what the case 2. So we're going to use the expression where acceleration is related to velocity and position right here, and we will multiply that position over 2 there and take the velocity here, so we can integrate both of those sides right there. So we go ahead and write the integral of 2880. I'll put some parentheses in there. And that's going to be dx. And we're going to take it from 20.4 to x, right? And for the velocity, we will take it from 11 to v. And you'll notice that that has to correspond with that, right? And we're going to use these, keep these as variables up in here. So if we do this integration, we get 2880x minus 72x squared going from 20.4 to x, and that's going to be equal to 1/2 v squared coming from 11 to v. Plugging all these in here, we get 2880x minus 72x squared minus 28,790. I just want to double check that because I have gotten the math wrong before when doing this. And that equals 1/2 v squared minus 60.5. So we can rewrite this whole thing out there by combining those constants there. And did I do that? Let's see. So if we set the velocity, okay, so for the things that we were trying to find, and I should have written down find up here, up at the top. Maybe is it too late to do that? Well, I'll write it down here. Find A was going to be the maximum velocity, right? So we want to find the maximum velocity, and so I just wrote down stupid somewhere in here, and so what do I then do? No, I don't think that's stupid. Okay, and then for part B, I wrote down we want the two positions, so I'll write down 2 positions when v is equal to 0. Okay, and so I can do that right here by setting the velocity equal to 0 and then using the quadratic equation to be able to find what x is going to be. So if I do that, and I didn't bother to write this whole thing out, which seems like a little sketchy to me. Why would I do that? 28,790, and we're going to bring that over there, so that's going to be added over to there. So 60.5. All right. So what we're going to do is take. See, I'm writing this out the wrong way. Negative 72x squared plus 2880x, and then minus 28,730. That's good enough. It's going to be equal to 0 when v is equal to 0. And then, so we're going to find the x is going to be, well, there's a bunch of, we can, I kind of prefer to rewrite this whole thing out. My eraser's dying here. So I could just write this as negative and that as positive right there. So I'm going to have negative b, so 2880, plus or minus the square root of b squared, 2880 squared, minus 4ab, right? So 4ac, duh, 72. It's been a while, right? 28,730. Hopefully that doesn't become negative inside here, or we get some issues. And that's divided by 2 times our 72. And Mr. Laziness would go to, let's see, we'll go to Wolfram Alpha, move you over to the side. Wolfram Alpha, and type in 72 times x squared minus 2880 times x, and then plus our 28,730. Boom. And I hope I get the same answer as I have written down here. Otherwise, it's really annoying. Why didn't you just give me the roots? Why did you just have to do it this way right here? Why don't you just give me the roots? Huh. As I get that's to be 19 and 21. Did I do anything wrong here? I think I must have somewhere. Let me pause it. Pause the video. Okay, resuming. I'm not sure why they don't give me the stupid numbers instead of being so clever with the square roots right there. Approximate forms. How about approximate forms? There you go. 19.01 and 20.986. Okay, good, because that's the same thing I just got by doing it out with the math right there. Okay, so that's the answer to part B. To part A, where we want to find the maximum, right? So we're looking for the maximum velocity. Well, the maximum velocity occurs when the acceleration is 0. So when does the acceleration equal to 0? Well, right here, right? Set it to equal to 0, and we could solve for x. So we say 2880 minus 144x equals 0, and that makes x is going to happen at 20 inches. So all we have to do is come back up to here and plug in 20 inches, right? So just 28, 20 inches minus 72, 20, whoop, can't see my writing, 20 inches squared, 28, 790. I don't know why I didn't write this whole thing out. V squared minus 60.40. Here. I like to put parentheses around stuff. So what we end up with here, according to me, is going to be 12.0 inches per second. So there is the answer to part A. So it's just some manipulation of the this equation right here. It's just manipulating this to try to get to the goals in mind, and it's the finding the maximum velocity and finding the two positions. And so I guess we could call that done.